Okay, yesterday we learned what properties. Okay, let's list them off. We learned the commutative property, keyword is order. Associative property, keyword is grouping. We learned the inverse property, keyword is opposite. And the identity property, keyword is mirror. Now we're learning today about the distributive property, and it's so special that it gets its own lesson. Okay, now one reason why the distributive property is so important is because it really is a building block, a foundational building block. What does that mean? It means it's a very core principle or concept in algebra. You are going to see this all the way through the higher level maths. Okay, distributive property is very important, and we're starting very basic. We're starting very simple to teach you how to apply it, and then we're going to apply it to variables. Okay, everybody should be paying attention up here. Okay, so in the first example, we're going to use numbers, numerical expressions. And here's what we're doing. You might look at this and say, Miss Kinder, I can solve this. I don't need to use distributive property. And I would agree with you. However, I'm teaching you how to write an equivalent expression. Okay, using numbers first, and then we're going to bring in the variables. So I need you to just follow the process. So with distributive property, what I'm doing is I'm multiplying the number on the outside by every term inside the parentheses. And I'm going to rewrite that. 2 times 90 plus 2 times 60. Okay, I'm going to write that out. That is my equivalent expression. Now I'm going to solve. I can solve it with either expression. I can solve it with this one or this one. It does not matter. Okay, so 2 times 150 gives me my answer of 300. Each one of these will have two answers. The first one is your equivalent expression. The second one is your evaluation. Okay, those are two answers. I want you to try B now. Give me an equivalent expression and then tell me what the answer is. Okay, evaluate it. Anybody want to tell me the equivalent expression? What is it, Jonadab?
15 times 4 plus 15 times 7.
Very good. Plus 15 times 7. Does it matter which way you solve? Nope. 15 times 11 gives me 165. All right, what about C? Somebody want to give that one a shot? What would be my equivalent expression? L'Oreal?
20 times 9 and 20 times 2.
Okay, and 20 times 3. And what sign goes here? An addition sign. Why an addition sign, not subtraction? Because 20 is positive. Okay, that's why. If 20 was negative out there, which you're going to see in a minute, then it would be a subtraction sign there. All right, so now we just evaluate. 20 times 12, 240. Okay, so 2 steps to solving, guys. Equivalent expression and then a boxed answer. Any questions so far? All right, example 2. Now in example 2, the first 3 are exactly like we just did, okay? Except now I got a whole lot of negatives in there. You think you can deal with it? You think you can do it? We'll see. Okay, so example A, this is very similar. Okay, so I just do 2 times 9 plus 2 times 2. All right, and then I can solve. All right, 18 plus 4 is 22. All right, 22 is my answer. All right, but now on B, I have a negative. So I still distribute my numbers. 6 times 11. 6 is positive, so there's still going to be a plus sign. But it's going to be 6 times negative 4. If it's negative in the original, it has to be negative in the equivalent expression. You have to keep the sign. All right, and now you can solve either way. 6 times 7 is 42. Or if you choose to solve this way, 66 minus 42, or sorry, 24 is 42. You see, guys, no matter which way you solve, you're going to get the same answer. Do you see that? All right. So write an equivalent expression and then box your answer. That's what we're looking for. I want you to try C on your own. All right, be careful of those negatives. Let's see who can get it right. An expression. Someone give it to me. What is it, Jonathan?
Minus 5 times 3 plus minus 5 times minus 14.
Okay, we're just going to call it negative 5 because 5 is negative. And instead of adding it, I'm just going to know that I subtract it because it is negative. Now, Jonathan, the way that you said to add the negative, technically that is not wrong, and you still should get the right answer. We just kind of want to veer away from using that double sign. All right, so there's my equivalent expression. Now I'm just going to solve negative 15 plus 70, different signs, subtract and take. My answer is 55. Okay, who got it right? 55? Good. Who got the equivalent expression? Okay, good. Good, about half of you. All right, so guys, it's a new concept. It's okay if you don't get it right off the bat. All right, now let's look at this second column. We're going to take a little bit of a different approach here. We see a number here in parentheses that maybe, now this one you probably could do in your head, but let's just assume for a minute that there's an easier way to break down that number so that you can do it mental math. Can anybody think of two numbers that added together would be 105 but would be easier to multiply? Two numbers that added together is 105 but just easier to multiply. Eric?
I just have a question on letter C.
Yeah, sure.
Couldn't another way to solve like you add the two numbers that are in parentheses together and get negative 11?
You absolutely could. Now, here's the thing. Now, you're evaluating on that. Here's the whole point to this, and you're going to see it in just a minute. You've got to be able to write an equivalent expression because in a minute, you will not be able to combine what's in parentheses. So you'll have to be able to write an equivalent expression to solve. We're just starting with numbers, but you absolutely could do that to get the answer. Okay, you're not wrong. Andrew?
27 plus 70.
All right. Anybody else, Cole?
100 plus 5.
Yes, 100 plus 5. So 4 times 100 plus 4 times 5. That's a lot easier. 400 plus 20 gives me 420. How can I break down 97? Is there a way I could break down 97 and make it easier, Nate? 90 and 7. 3 times 90 plus 3 times 7. 270 plus 21 gives me 291. What about 2.9? What do you think, Andrew?
2 and 0.9.
Yes. 5 times 2 plus 5 times 9/10. 10 plus 4.5. 14.5. All right, so what we're doing on these is we're breaking down that initial number into two numbers that can be added together to equal that number, but they're just easier to multiply. Again, I'm applying the distributive property here. All right, so this is what it looks like with numbers. Now here's the turning point. Now we're going to work it with variables. Now, before we do that, I want to come over here just real quick to the whiteboard, and I want to work a problem real fast that we did yesterday. Yesterday we learned 2x plus 6 plus 3x minus 8. We learned a concept called combining like terms. How could I simplify this expression? How could I simplify it, Alex?
Add the 60 to 8.
Add 6 plus 8? 6 plus 8? L'Ariel?
The 2x plus the 3.
2x plus 3x plus 6 minus 8. What property did I just use? The commutative property. So now I have 5x minus 2. And this is it. This is my final answer. Why is it my final answer? Why, Emily? I don't know the value of x. I cannot combine a variable with a number that stands alone. I can combine terms with the same variable, but not with numbers that stand alone. Are you listening? You listening? Pay attention. Look up here. Okay? So now let's go back to the slide. Here, I cannot combine what's inside the parentheses. We just talked about that, right? I cannot add it together, but what I can do is I can multiply it. So here, I have to create an equivalent expression to get rid of those parentheses. Okay? To get rid of this term that I cannot simplify, I've got to now use my distributive property. I can multiply it 3 times x and 3 times 7. 3 times x, okay, a variable that stands alone has an understood 1 in front of it. So 3 times 1x would be 3x. And 3 times 7 is 21. So here's what I do. I'm going to write an equivalent expression. So I write 3 times x, or I know that it's 1x, plus 3 times 7. There's my equivalent expression, and now I can simplify, equals 3x plus 21. Equivalent expression, boxed answer. The difference here is you cannot get to the answer unless you write an equivalent expression first. Eventually, guys, are you still listening? You're going to do this in your head. Eventually, you'll just do it in your head. For today, and while we're learning, I need you to write this step. All right? So, step 2 right here, I need an equivalent expression. I want you to try it, and then we'll go over it. Got to write it, though. Did you write your equivalent expression on your paper? Negative 2 times n minus 2 times 4. This is your equivalent expression that they want you to write. Now, here is your answer. Negative 2n minus 8. Now, if you said plus negative 8, that would be okay as well. All right, now I want you to try C. So if you missed B, try to get C right. I need an equivalent expression and then your simplified answer. There's not going to be an exact answer because you don't know what y equals. Okay? But I need an equivalent expression and a boxed answer. All right, so we have negative 5. Guys, what we're doing is we're multiplying negative 5 times 2y. Show that. Negative 5 times 2y. Now let me ask you this. What do you do now? Do you add or subtract? You subtract because 5 is negative. Minus 5 times what? Negative 3. You are basically writing what you are thinking right here in this step. This is the mental process that you're thinking when you're solving. Now, your last step is to simplify what you can. What is negative 5 times 2y? What's negative 5 times 2? 10. Negative 10y. What is negative 5 times negative 3? Positive 15. And this is my simplified answer. Equivalent expression, boxed answer. You see? Okay. All right. Now I want you to practice these 4. Okay? I need 2 things. What do I need? Somebody tell me. What am I looking for? Equivalent expression, simplified, boxed answer. So equivalent expression, write what you're thinking, what are you multiplying by, and then box your answer. Okay, equivalent expression, 8 times x plus 8 times 2. Sound kind of robotic? All right, and then you have 8x plus 16. (8x plus 16). All right, next. Are you watching? Negative 4 times 7. Did you write that? Plus or minus? Minus, because 4 is negative. 4 times what? negative t. What number do we know is understood in front of the t? 1. Okay, so we keep that in mind when we're multiplying. What is negative 4 times 7? Negative 28. What's negative 4 times negative 1? Positive 4t. Who got that one right? Awesome. Good job, guys. Do you see where you went wrong? Does anybody have a question? Okay. Got it? No, backwards is fine. If you said 4t minus 28, that's perfectly fine. As long as you got your sign right. If you said 4t plus 28, that's wrong. Okay, you've got to have your sign right. All right, now, equivalent expression, 9 times 3m plus 9 times 5 equals what? 27m plus 45. Who got that one right? Awesome. Very good. Very good. Last but not least, lots of negatives. Negative 2 times 6y minus 2 times negative 4. So that is negative 12y what? Plus 8. Y positive. Because how many negatives did I multiply? 2 negatives. Did anybody get all 4? Awesome. Did anybody miss 1? Okay, very good. Last example, we're finding an area of a geometric figure. I have a, what kind of shape is this? It's a rectangle. What is the formula to find the area of a rectangle?
A equals L times W.
Use the distributive property to find the area. Let's see who can do it. All right, so we said area equals length times width. So area equals, what's my length? 2x plus 5 times 7. So I cannot, here's my problem. I can't add 2x plus 5. So what do I need to do? Distribute the 7. Distribute the 7. So area equals 7 times 2x plus 7 times 5. Area equals 14x plus 35 units. Units what? Squared. Who got that right? Awesome. Very good. Guys, that's it for today's lesson. If you understand that, that's everything you need to know for 2.2.